Hello students, today we're looking at the parallel postulate and its converse. So the essential question is, how do I find missing measures when parallel lines are cut by a transversal? Your learning intention, I'm learning to find missing measures in parallel lines cut by a transversal. So you've got a warm-up question. This was over what we've already learned. Can you find all the missing angle measures? Okay, you can find 4 of them with no math at all. But which 4 are they? The lines are parallel, so which ones will be congruent? Well, let's get started. If this one's 136, the vertical angle has to be 136 too. This is 136 degrees. Okay, corresponding angles. If this one is 136, then this one has to be 136 degrees also. Now we finally get to X, which is a vertical for this one, so this one, or a corresponding for here, so this one is also 136 degrees. Without any math at all, I found 4 of them. What about the other 4? How do I find them? Well, if they're not congruent, then they are supplementary. To find the other 4, supplementary means they add up to 180 degrees. 180 degrees minus 136 degrees is equal to 44 degrees. Any questions? The rest of them are all 44 degrees. And we're done. That brings us to today's lesson. What is the parallel line postulate? Remember, a postulate is something we accept as being true without any proof. In other words, we cannot prove this, but so we just accept that it's true. The parallel line postulate states, if parallel lines are cut by a transversal, then corresponding angles are congruent. Probably should have used the symbol for parallel on the first line, but that's okay. So if parallel lines are cut by a transversal, then their corresponding angles are congruent. The converse changes the hypotheses with the conclusion. So we start out, if corresponding angles are congruent, then the lines cut by the transversal are parallel. Let me move it up so you can see this. Okay, so if they're parallel, then the corresponding angles are congruent. If the corresponding angles are congruent, then the lines are parallel. So if you're looking at the picture, it says find y and z and find all the angle measures. Okay, so looking at all this, I know that these two lines are parallel and these two lines are parallel. So you've got two pairs of parallel lines. So if I am looking, x is probably as easy to find as any of them. What do I know about x? X and 106 are same side or consecutive interior angles. So the question has to become, are they congruent or are they supplementary? If you said congruent, you would be correct. So I know x plus 106, x degrees plus 106 degrees is equal to 180 degrees. Subtract 106 from both sides. And x is equal to 74 degrees. Okay, now, I claim that we know all of the angle measures. We might not know what the variables are, but we do know all the angle measures. So if I'm looking at this, if this is 74, this one is 74, this one is 74, and this one is 74. Wow. Now I've got an easier problem. 2y is equal to 74. That's 74 degrees. Divide both sides by 2. And y is equal to, half of 74 would be 37 degrees. Okay, now let's go ahead, because these lines are parallel also. So if this is 74, I know that this one has got to be 74 degrees. This one has to be 74 degrees. 74 here, and 74 here. I think I've got all the 74-degree angles marked. Let's go for the 106. 106, this is vertical, 106. This is corresponding, 106. Vertical, 106. And let's see, this is 106, this is corresponding, 106 degrees. Vertical, 106 degrees. Corresponding, 106 degrees. Vertical, 106 degrees. Now, it might be an easier problem. I don't know, we'll see. We know that 4z plus 6 is equal to 106 degrees. Step 1, subtract 6 from both sides. And I've got 4z is equal to 100. That's 100 degrees. Divide by 4. And z is equal to 25. And that would be 25 degrees. Okay, so as you can see, once you figure out the pattern, the math becomes fairly easy. So let's look at the next. We're always wanting to prove things. So we're going to look at these two pictures and decide whether there's enough information to prove that M is parallel to N. If so, state which theorem. Okay, so as I'm looking at the first one, I've got two angles that they tell me are congruent. This angle is congruent to this angle. What kind of angles are those? Well, they're corresponding angles. So if I'm looking at my two theorems, I would use the converse of the parallel line postulate. If your corresponding angles are congruent, then the lines are parallel. So yes, they are parallel. M is parallel to N by the converse of the parallel line postulate. Okay, look at the next one. Is there enough information? Is there enough information to prove that M is parallel to N? What can we, first of all, are the angles congruent? What theorem would we be able to say they're congruent by? The vertical angle theorem is correct. So if you're looking at this, both of those angles are on one line. We have no idea what's going on with the other. So in this case, there's not enough information because we know nothing about the angles on line N. So, in this case, corresponding angles, and yes, it is parallel. In this case, we don't know because we know nothing about the second line and its angles. So, let's get started. Find the value of the variables in each figure. Find all the angles measures and explain your reasoning. So if I'm looking at this, first thing I'm going to do is cover this up. It's not going to help me much to try to look at all of those lines that are parallel together. So as I cover it up, I've got to decide, are the two angles congruent or are they supplementary? If I want to mark my congruent angles, this angle and this angle will be congruent. This angle and this angle are congruent. So by marking those, I know that they are not congruent, but are in fact supplementary. That means when I add them together, I get 180 degrees. (5y minus 4 plus 3y is equal to 180 degrees. Combine your y values. 5y plus 3y. 8y minus 4 is equal to 180 degrees. Add 4 to both sides. Eight y is equal to 184 degrees. Last step is to divide by 8. Y is equal to, in this case I'm going to grab my handy dandy calculator. 184 divided by 8 gives me 23. Okay, so let's figure out what the first one is. 5y minus 4. 5 times 23 minus 4. Once again, for speedy's sake, 5 times 23 minus 4, and I'm given 111. Okay, so I want to go, now I'm going to look between these two lines, and I'm going to highlight the ones that are congruent. So the corresponding angle here is here. This corresponding angle is here. These are vertical. So I've got all the ones that are 111 degrees marked. Okay, now I want to find the rest of them. I know that the rest are 3y, which means 3 times 23. 3 times 23 is 69. So everything else is 69 degrees. Okay, now I can find x fairly easy because I know that 2x plus 13 is equal to 69. Now it's a matter of a two-step equation. Subtract 13 from both sides. 2x equals 56. Divide by both sides by 2. Okay, so half of 50 would be 25. Half of 6 is 3. 25 plus 3 is 28. Always put your little degree symbol there. So, by knowing which ones are supplementary and which ones are congruent, we can find all of them. When I did this, could I have taken 180 degrees minus 111 degrees? Yes, that would have been perfectly acceptable also. You still would have gotten 69 degrees. So your summary: I know I am successful when I can find missing measures when parallel lines are cut by a transversal. So we're looking at parallel lines, specifically the congruent angles and supplementary angles.